So in the last video, we learned about what a subspace is, and the only ones we really talked about were just spans, so spans of vectors. Now let's talk about some very specific subspaces, two in particular. So we're going to talk about two special subspaces that will come up quite a few times in our class. They're going to be the column space and the null space. All right, so I'm going to define them both for you. Column space, let me try that again. COL of A is what we're going to use to denote a column space. All right, and so this is just defined as the span of the columns of A. And so if you wanted to break down A into column vectors, it would just be the span of A1 to AN. All right, so just take the columns, do a span of it, that's the column space. NUL of A, known as the null space, well, this is just all of the solutions of the homogeneous system. So all the solutions of AX equals the zero vector. In set notation, it's going to be all X in Rn such that AX equals 0. All right, so one of these takes more work to find than the other. That's okay, we're going to talk about how to find both. All right, let's look at an example. Let's look at a matrix A. So we're going to find the column space and null space of our matrix A. So A is a 3x4. Down my columns, I got 1, 3, 2. -3, -9, -6, 5, 6, 0, and 1, 1, 1. So this is the matrix A. All right, so first we're going to find the column space of our matrix A. Remember, it's just the span of all of the columns of A. All right, span of our columns. 1, 3, 2. Okay, so this is our column space. And the column space is always going to be a subspace. So is a subspace of R3. Bam. First one, straightforward, good to go. This is our column space. All right, so what will take a little more work is our null space. So let's work on finding that. So what is the null space of our same matrix A? So whenever you're asked to find the null space, you are going to have to solve the homogeneous system because the null space are the solutions of the homogeneous system. So all these X values, that's going to be our null space. All right, so how do we solve the homogeneous system? Well, we need to set up an augmented matrix, right? With A on one side, 0 vector on the other side. All right, and then I'm going to put it in RREF. It may take some work. I'm going to skip the work for the purpose of this video. Okay, so when we do row reduce to RREF, I have down the columns 1, 0, 0, -3, 0, 0, 0, 1, 0, and 0, 0, 1. Okay. Okay, so this is what it looks like when we do an augmented matrix and row reduce it. Let's go ahead and find our general solution, and then we're going to put our general solution in parametric vector form. All right, so remember we have x1, x2, x3, x4 to solve for. So x1 looks like it's going to be 3x2, which means our x2 is free. X3 is 0, and x4 is 0. Okay. All right, so now we're going to write this in parametric vector form because that is going to help us with our null space. All right, so notice that all of these have, so I'll do it in multiple steps. First step, you can skip this step, but write what we have just as a vector. 3x2, x2, 0, 0. And now I can factor out the x2, right? All right, so that means every solution to our homogeneous system is going to be a scalar multiple of this vector 3, 1, 0, 0. So every linear combination here. All right, so that tells us we got a span, which is going to lead us to our subspace. So the null space of our matrix A is going to be the span of 3, 1, 0, 0. Those are all of the solutions for our homogeneous system. All right, so this is a subspace. And this is a subspace of R4, right? Because these vectors are in R4. So notice that our null space is in R4, but our column space is in R3. That's because they're talking about different things. The null space, the column space is all of the columns, and it depends on how many rows we have. It's in R3. However, the null space is the solutions, x1, x2, x3, x4. So we're going to have 4 positions. All right, so that's all for now with these two subspaces.